Hey, it's Penalized Math Industry, and we are going to take a look at mechanical waves. So recently, we've been learning a lot about the different types of waves and how to measure them. We drew pictures. We've also learning about how we can understand them and what they are. But what we're going to talk about is the mechanical waves. So, mechanical waves are types of waves that must require a medium to pass through. A medium is something like water, air, a blanket, or anything. A vacuum like space is not a medium. Just like waves that are mechanical are like sound waves, strings, guitars, water waves. Yeah. Light waves are not mechanical waves. Neither gamma rays. We could also learn about transverse waves and longitudinal waves. Transverse waves have particles moving perpendicular to the wave motion. So these are the most common types of waves that you will assume and also think about. The ones that easily just go up and down, up and down. And they're going to go transverse because they're always going to be transverse from the direction of where they're going. Up and down when this is going to the right. But if you talk about longitudinal waves, they are parallel into the wave motion. Trying to graph it or trying to picture it on a piece of paper is difficult, but I'll try my best. So basically, it's waves that are smashing and compacting together. Just like a slinky would. When you slightly jerk the slinky forward, it would make a wave compressing and retracting as it goes to the right. And it's parallel because it's going to the right, while the compression and the reaction is going to the right too. So those are longitudinal waves, just like sound waves. Those are examples of a longitudinal wave. So here's what we're going to try and do. Try to solve a physics problem relating to waves that are mechanical. Well, here is the problem. If a guitar string is 0.6 meters long and has a mass of 3 grams and is tightened to a tension force of 15 newtons, what is the velocity of the wave? So we're trying to find how fast the wave goes when moving from left to right. But a guitar string goes up and down like crazy. A guitar string produces waves because it's a repeated motion. And it also vibrates because not only it vibrates, but it also vibrates to make a sound wave. Haha, 2 waves at once. There are 2 formulas that we'll be needing to help solve this problem out. The first one is V equals that symbol multiplied by F. So that is saying the velocity is going to equal the wavelength multiplied by the frequency. So the frequency is basically how many bumps or how many waves are passing in like 1 second. And the wavelength is, from the last video, we learned the distance between the crest, the middle, or the trough. And the velocity is the speed of the wave, what we're trying to find. There's another formula that we're going to try and look at. Since the guitar string is tightened at a tension force of 15 newtons, there's another formula. So if the string was stretched, or is stretched, the velocity equals the tension force, divide that by the mass, divide that by the length of the string. But when you do all that, you have to square root all of the numbers to get your velocity. Here's what's going to happen. Let's do the math. So we're trying to find the velocity of the wave. So it makes sense that we're using the letter V. But we have to square root a giant square root symbol. The tension force is 15 newtons, so we're going to put 15 right here. We have to then divide that by the mass. But 3 grams is not the right kind of mass we're trying to look for. Yes, it used the metric system, but it's not that. What we need to try and do is try to do in kilograms. So 3 grams is 0.003 kilograms. But then we have to divide by 0.6 because that is how long this string is. How fast will the wave go when you pluck the guitar string? And you have to add parentheses because of PEMDAS, or order of operations. You have to do stuff inside the fraction before you do stuff in the square root. So, when you do 0.003 divided by 0.6, you get 0.005. But then we have 15. Divide that by 0.005. You get an astonishing of 3,000. But we still are not done yet. We have to use that gigantic square root. So the gigantic square root of 3,000 is going to bring us to an answer of our velocity is going to equal 54.8 meters per second. That is really, really fast and makes a lot of sense because waves tend to travel at very, very fast speeds. To the point where if they're very small or have a high frequency, or if they have a period which is very fast, or periodic motion, or repetitive motion, is too fast for the human eye to see. And when you see that guitar string pluck, when it wiggles back and forth, it vibrates. The waves are actually too hard for the human eye to kind of picture it per frame and see it. So yeah, we have solved a physics problem related to mechanical waves. I hope this video has helped you understand mechanical waves. Thank you for watching Top Opinion Line's Math Industry. Like and subscribe!